That big enough? Can't tell. That big enough? No, and I don't want to hear myself tell. That big enough? No, and I don't want to hear myself tell. That big enough? No, and I don't want to hear myself. No, and I don't want to hear myself. No! No, and I don't want to hear myself. No! Done. Alright, I think that's enough. So, let me just clean that. I can't remember when the last stream was. I think it was at least 10 days. It was at least 10 days ago, right? Let me check YouTube channel. Let me bring it up on the front big screen. Yeah, obviously, you can tell there's a lot of things different with my setup. I'll explain that later. Alright, I'll bring up my YouTube channel. Okay. 10 days ago, yeah. So it was 10 days ago. And it's been a long time. Really. You know, I watched my channel grow into what it is now, like the 542 subscribers, like 10,000, like 10k views. And I watched that happen while I was bedridden. So I'm not sick anymore, right? So I can stream. So I'm gonna spend all of this time doing things that I've been thinking of while I was sick. So while I was sick, I was thinking how I could do the type system. I was researching, and I wrote a ton of stuff. In the obsidian. What else does this guy say? Your vids go hard, bro. Always on my feed. Algorithm loves. Yeah, yeah, they do. It's crazy. 542 subscribers. The algorithm has picked up my videos and shut it up like crazy. I wish I could like reply to every single comment. I'm eventually going to. I should. I mean, yeah, they're blowing up like crazy, and I just made my channel, not that long ago. Yeah, so 542 subscribers, which is great. Yeah, thanks. So, what's on the agenda for today? It's a couple of things. Let me bring it up. Alright, so things that need to be completed before I can start working on the intermediate representation. So, mutability, slices and array construction, raw pointers, and like effects. So the IO type system. And effects mean things that make a function impure, like printing, right? So let's try it. This is a function that just prints something. Hello, right? When you call this function, you can't cache its value, right? You can't cache its value. It produces an effect on the outside world. So it's an impure function. So I need to do that, integrate that in the type system. Yeah, so IO type system. Yeah, with all extern functions, you most likely will come with IO. And then this is short for okay, this is not short for that. This is short for that's short for T, IO, and then T. That's return of time. Okay, partial function application optimization. I don't know about that for now. Yeah, here. I mean, what else? I don't know. I don't know what really I did while I was gone. I think I did here. This is what I did. I did labels. Let me check. Let me check the git log. By the way, my setup looks a lot different. This is because I blew away my whole computer, and my whatever's behind me looks different because I rotated my whole table. So everything looks a lot different, but still the same code base. So not much has changed though. Where is it? So that's init 2. I'm looking for the 5th stream here. Checker 5. Initial type checker and infix promotion. Yes, that's what we did last stream. And what did I do since then? Implicit integer type. Yeah, fix duplicate vars in the same scope. Yeah, that was a bug that was molding over last time. Last stream. Yeah, so pub statement. Yeah, so I also did like statements public to the module, so you can export things in the module. Right now it's currently broken because I'm changing the syntax for that, and you'll eventually see that. Yeah, resolve cross module symbols. That's just a simple AST traversal. Yeah. Oh yeah. So I did I did blocks. I did blocks, and I'll show you that here. Hope the quality is in that. It's pretty good. Okay. So we'll write like a function like add, takes in x and y and returns x plus y, right? But what if you want to make this you can make this a block by putting a do, and then we can show the output of that. Yeah, so this is a do block. The last expression in a list of statements is the return value. See how it was add x and y equals do, and a bunch of these. The last one here, it's always taken as the value of the block. So this is break. Yeah, so it breaks with the value of x plus y. And this is an implicit break. What you can do is a explicit break. So you can use the brk keyword. Oh yeah, non-cycle loop. Yeah, so you can do a manual break and you can do an explicit break. And when you do an explicit break inside a do block, it has to have a label. So this is the what's it called? The L label. Break here to here, and then that works. Yeah. So and then it breaks out of the loop like that. Breaks out of the block. So this is just like Zig, right? This is basically just like Zig. So you have your label and you have your breaks here. The only thing I change is that you shorten the keyword, so it looks a lot nicer. I mean, I like shortened keywords because in assembly you have the ret instruction, and it's a shortened form of return. I don't know. I just like short forms. So I'm gonna use break for break, brk, because it looks nicer. Hold on, just reload. Okay, stream's still going. Yeah, so you can break out of a do block, and this is just a list of expressions. So, but there's also another keyword called loop. It's just a loop keyword. It infinitely loops. And it's an expression, so it takes so with the keywords loop, and then right after it takes an expression. So you can just do loop do break x plus y. That should work, right? Yeah, it works. So yeah, so this loop eventually evaluates to a value x plus y, and it returns that. So let me run the type checker. You probably want to see it with the type checker on. Yeah. Let's run it with the type checker. ArchUser64 says hello. Hi. Thanks for coming. I've had a lot of attention while I was sick, so, and I've watched my channel blow up. This is my first stream since I've been sick, so I'm back to do more programming. Yeah, so I'm gonna run the type checker, and I uncommented it. Yeah. Oh yeah, function type inference is not implemented yet, so let me just write an explicit one. Yep. And run it. Okay. Yeah, so this is a loop expression. This loop expression takes in the do block, and then this break does not refer to the do, it refers to the loop. So it just breaks with x plus y, and that's what the loop does. It'll immediately enter the do block and break with x plus y. Being sick sucks. Glad you're back. Yeah, it does. It was the worst sickness I've ever had in my life. It sucks, but I'm back, and I did some research. I was like looking some stuff up while I was sick. So, but I'm back now. So that's what I'm doing. Yeah, so you can see here, this is and you can also remove the do block because break is an expression. The break is an expression which evaluates to the no return type or bottom type. People call it bottom type in functional programming areas, and people call it no return in imperative programming areas. So this is what Zig would call it no return, but really the break keyword just signifies that you're breaking out of this current scope, and it evaluates to no return. Yeah, so even this is legal. This is legal as well. The loop takes in an expression, and that expression is break, which breaks with that expression. And you can also loop forever. Type mismatch. Expected I32 got this. Okay, that's not right. Yeah, looping forever evaluates to the bottom type, which is this. And it, yeah, if I can just do 0 plus this. This will just trick the checker right now. Oh. Okay, well, the type check is broken, and I'm gonna rewrite it this whole stream. Yeah, so you can see here, loop, using static analysis, or like the compiler can easily see that the loop has no breaks, which means it'll never evaluate anything. It'll constantly loop. And that's equivalent to no return, right? You can just make this return no return. And the no return type, which is the bottom type, it is the, like, what is it? The parent of all types. So this type can always coerce into any other type. So this is legal. This is legal. So I32 takes an I32, returns an I32, but really it just loops forever. Spider-Man says, hello. Hi. This is my first stream back from a while. I'm just explaining, like the no return types. Okay, so what I did when I was gone, I did loops, and then breaks. So you can break with the value, and the no return keyword. So this will just evaluate to this, which means it'll never return, which means infinite loop. You know, what else did I do? I did if then else. You know what? Let me check out this one. Your local trojans will be overridden. Okay, let me stash. Check out. And then run. This will probably help in showing. Yeah, I did so I did booleans. I did booleans as well while I was gone. So n is a function that takes in I and returns the inverse of I. And that's pretty simple. And yeah, main. Yeah, so it'll negate here. So just negate all the way down. So I did booleans. Yeah, let me check out to another one. Is it when I did if statements? Yep. So here's some if statements. I'll explain how they work. It's just if dot then dot else dot, and that's 3 expressions. That's basically our ternary operator, but also you can do an imperative if statement. So you can do if then, and you don't need the else. So this always evaluates to void. So you can have a imperative if statement. So you can have the condition and the then, but no matter what you have inside, it'll always evaluate to void. Yeah, it'll always evaluate to nothing. But this will always evaluate. This ternary it'll always evaluate to something based on the 2 inner expressions. So yeah, that's two different. That's just 2 different types of if expressions. Yeah, so if c then v equals that, and then just return the value of v in the do block. That's pretty simple. What else did I do? Yeah, so that was stream 5. I did imports, but that's not important. Eventually, I'm gonna have to fix all of that up. later. Today we're gonna do something different. Okay, let me do a get. Get reset. Get. Okay, and then I'll bring back my stuff. Get stash. Head detached. Yeah, I don't know get. Like I wish I knew get. What's it called? Please commit your changes to stash before you merge. Yeah, what do they change? Okay. Good. And then get stash pop. Yep, bring back all the stuff. Okay. Now, I'll explain what I was doing, what I planned for this stream. Yeah, get checkout b some name, we'll make it not detached. Then create it. Yeah, I just wanted to wipe out all the stuff I had before so I can get stash pop. That's just the annoying thing to get. Okay, I'll explain what I wanted to do this stream. I'll bring up Obsidian. I go to the type checker. Okay. So this is the current rules for type inference. The type of a value must always be determined at its initializer. This is the main kicker that how the type checker is worked. You'd have a variable declaration and you'd have an expression, and that would always be the type, right? It'll calculate the type. This is how it works in other languages like V and all these things. Yeah, so the type all variables have an initializer, and the type is always determined at that initializer. You can't have things like v equals. You can't just like define a variable and then not assign it something. And that's how most languages get away with type inference. They just do singular type inference at the point of initialization, and that's how it was in this language. Yeah, so you can see that here. This is type inference rule. So yeah, so 1, the type of the variable must be determined at the initializer. Functions don't always need to be typed, their uses will determine the type. And functions need to be explicitly typed to be polymorphic or generic. Yeah, so that's the 3 type rules in this programming language. And so number 1 is what I explained. And number 2, functions don't always need to be typed. So add AB equals A plus B. You don't really need to type this, and it'd get annoying if you did. You'd just be going I32, I32, I32 over and over. Yeah, you would not want to type this, especially in a language with syntax like Haskell. It would get old very quickly. So, and how I want to accomplish this would be done during the stream. Yeah, and 3, functions need to be explicitly typed to be polymorphic / generic. Yeah, so the way we are determining the value of this function, like the type of this function, is by its uses. So if you add 20, it'll infer that this type right now is this, right? It'll infer now that the type is an I32. You'd use it again. It would infer that the second argument is an I32, and then with these 2 things, it can substitute them here. Substitute, and then determine the type of the function. That's basically how we're doing it, and this it results in functions that aren't generic. Like, these functions aren't generic at all. If you want generics, you need to make it explicit. So t returns a t. Yeah. So things get a lot easier when you do it this way. Okay. Yeah. Yeah, non-polymorphic by default. So this is just a bunch of rambling about the Hindley-Milner type system, and I'll bring it up here. Hindley-Milner. Okay. Yeah, it's a type system for lambda calculus with parametric polymorphism, and that means essentially generics. It means generic over their inputs. So that's parametric polymorphism. Yeah. Yeah, or Damas Hindley-Milner. Yeah. Among HM's more notable properties are its completeness and ability to infer the most generic type of a given program without programmers applied type annotations. Okay. This is basically languages like Haskell that would use Hindley-Milner type system, Scala, all these functional languages that permit really high type inference. Languages like Rust use this as well for closures. So this infers polymorphism, so your generics, and it would infer the types of other variables. And how it works is you insert type variables in places where you don't know the type. Yeah, MLs also. Yeah, like OCaml and all of those things. They use the Hindley-Milner type system. They use specific properties about this thing, and most of them implement algorithm W. Now, I don't understand this at all. Like, I mean, I wish I understood all of these logical operators, but you don't really need to know any of these. You just need to understand some very simple things, and that's what I'm going to be doing this stream. Basically, since we don't infer polymorphism, so I wrote that here. Yeah, functions need to be explicitly typed to be polymorphic and generic. Functions no longer need to be inspected for the polymorphicness. That's basically it. So we don't need to like algorithm W is nice. Like all of these other languages use it to infer polymorphism. But in this language, I want to make things a lot easier, especially on a compiler implementation perspective. So I won't make it's not going to infer what's it called? Polymorphic or genericness. The type of a function will always be determined by its use. And that'll make things a whole lot easier, really. And when you remove inference of polymorphism, the application of Hindley-Milner becomes so trivial, right? So let's say you have a let a equals something, and it'll assign it a type, an unknown type, and then you'd call it with a function. Let's say this function takes an immutable i32 and returns nothing, and then you do mut a. It immediately knows that is an i32 because a is being here. Like undefined. Yeah, a has currently no type, so this is like a type variable, and then when it gets called with function and gets inputted, you can substitute the i32 type for this type variable, and that's what we're going to be doing this stream. We're going to be creating type variables, assigning types to them, and allowing just for basic type inference, and it'll make things easier. Yeah, so find and replace semantics with typevars. So a typevar is basically I think I explained how the type system works, how the type system in this language works. It's all types are represented by a type T. This type T is basically a type def for a unsigned 16-bit integer. So that's an index into a type table. And all the built-in types are basically, I think I reserve the bottom 20-ish numbers in type T for built-in types. But anything higher than that, you subtract 20, and then you get 1, and that's your index. That's your index into the type table. I know it's not 20. I think it's like 16. It's a macro. I think it's like type concrete. Yeah, 21 minus type concrete equals your index into the table. And what you can do, basically, I think we'll be able to call typevar new, and then get a type t, and then replace all instances of this typevar with another type. That'll make things a lot easier, that API. Yeah, and the I also did a little thoughts on how the IO effects system would work. So let's say you have a main function, main equals do, right? And it's got to do something, so you print something. The print function, the print is just defined as this. Print is just an IO that takes in, I don't know, something. Let's make that generic. Yeah, so and then it just prints hello world. And print, this would basically evaluate to IO. Yeah, so it will evaluate to IO. And then in this do block evaluates to this. And then also, since it has an effect inside its body, it evaluates to IO. That means main takes in nothing, returns nothing, but exhibits an effect. Yeah. Spider-Man says, if you have it be a power of 2 instead of 20, you can just use a bit masking. Well, I think you're misunderstanding how it works. It's just I just reserve the bottom, I think the bottom, not the bottom 20 bits. I mean, I reserve literally 20, like the numbers up to 20, and then I subtract those numbers, and then yeah, so let's say you have an i32. Its type is type i32. Here, I can even show it in the in so all.h type. Here we are. So let's type concrete lists, concrete literals. Yeah, so type i32, and let me use it in main. T equals type i32. Yeah, so i32 has a value of 2, and all of these things have an integer value, and they're used here. Yeah, in type kind. So it has a concrete list up to concrete max. Yeah, these are all X macros. These are all X macros. That's how I like to do things in compilers. I just have a list of all the types, and I slap them in an X macro, and I run over them in an enum. Yeah, so type concrete max. So this is an enum of 15. So let's say you have a type. So i32 is just type i32, and that's just like 3, right? And let's say you have something like a pointer to an i32, and this is a type ptr, and these don't reside in the just a normal like concrete address space. So this type ptr will be less than type concrete. So yeah, this will be more than type concrete, because it's not a concrete type. So to get its underlying index into the type table, you need to take your type, say type t minus type concrete max, and then you get the type. Yep, and then now you can index. Let me go to the type definition. Yeah, type info. Yeah, and then kind equals type ptr. Yeah, so let's say you have type t, and that's stored in your variable type t, and it's an i32 pointer. It's an i32 pointer. So if you wanted to find its location in the type table, it's t minus type concrete max, indexed in the type table, and if you check its kind, it'll be a type pointer. That's how it works. Yeah, Amit Singh is used all over the compilers that are written in C and C++ to define keywords, literals, etc. Yeah, I use X macros all the time. Okay. Now let me get to, yeah, it's mostly written in abc.def and then included wherever needed. Yeah, I used to do that. In one of my older compilers, the older one of this, I just included it in like a talk.def, but it really felt a lot easier having everything in this like polyglot header file, having it contain everything. It just got out of hand, so I'd rather just dump them all here. It just seemed easier to me at the time. Okay. And this is what I was doing while I was sick. So I wrote a little bit of algorithm J, and back then I didn't really understand how it worked, but now I think I can do it. So I think I wanna remove this file. Yeah, so this is degeneric. So I can remove that. Okay. I saw Swift compiler, where I also use Python with X macros. Python? Hold on, let me blow my nose. Yeah, still sick. Okay. So these are the list of types. And in here we have a type, just type _var. And you'll be able to create them and replace them with this. Typevar new, typevar replace. Typevar with type. Okay. Yeah, I'll put this in here. Okay. Yeah, return type new. Typevar, and then D typevar. I don't know what I put for it, for a typevar. Oops. There we are. There we go. Okay, now it's just a typevar ID, which is a U32. I don't think I'm going to do it that way. I think I'm going to make... D typevar. Okay. Okay, so if a typevar, if a typevar ref is type infer, which is just -1, it doesn't have a type. That's how I'm going to do it. Okay. Emit sing says dynamic or static. Are you going to use llvm, eval on AST, or VM? Okay. This language is going to be compiled. I'm not going to use llvm. I have specific opinions on llvm. I don't like it at all. So it'll be a statically compiled language, static types. All types will be known at compile time. Yeah. So my mode of compilation won't be llvm. I think I'll probably use C initially, and then I'll go for WASM immediately for the bootstrap. The reason why I want to output C, for multiple reasons, C is just a really nice thing to output. But I want to output C because I want to be done with this bootstrap compiler as soon as possible. Like, I want to get out of C and start writing some real functional code in my own language. So once I'm done with C, I can just start writing in this language, and then I can start working on the WebAssembly, outputting WebAssembly, which will make things a lot nicer to work in. So it'll be a statically compiled language, no llvm, none of that. It'll just compile C initially. Yeah. Well, it's gonna be a lot more than transpiling, I'll say that. I'm not gonna be once I finish working on the type checker, I'm gonna start working on some really low level intermediate representation. So it'll be a basic. It'll be like lists of basic blocks. Uh, it'll have a ton of passes, and only when I'm done with those passes, I'll start outputting C. And this won't be any pretty C as well. It'll be full of go-tos. So I wouldn't say it's transpiling. I'd just say it's just using C as like a portable assembler. Yeah, it won't look like anything pretty. That's why I wouldn't say it's transpiling. Okay, and then typevar replace. Yeah, typevar replace. We'll just get a set type kinds. Okay. Yeah. Type info do typevar ref plus type. Yeah, using C as a compiler target is underrated. Yeah, that's right. It makes things easier initially. Alright, so this is the type checker as it is right now. It's not very sophisticated. I think it's mostly like what we left off with in the fourth stream, right? Yeah, the fifth stream. C++ did that initially. Yeah, and I remember some modern language doing that. Yeah, V does it. Okay. Yeah, so this is the type checker. Right now, it doesn't do anything sophisticated. It doesn't check function types. Well, it does check function types. It just does not perform inference. And all of these things. Okay, so right now I'm gonna make a copy of this. Remove the .c. This is how I usually do things. I'd make a copy, remove the .c, so it doesn't get picked up by the glob, and then I'm just gonna delete all of this. And what does it say here? See top level. Okay. I'm gonna delete all this. Just delete. Do I need to delete all of this? Okay. I forgot what I want to do first. I'll make a minimal. Yeah, A equals 20. Yeah, I'll add the I'll do the undefined keyword now. This is the undefined keyword. All it is basically like, let's say int a equals something. This is in C. Assigning undefined is equivalent to this. Right? You're not assigning it. And I'm basically stealing this out of Zig, because Zig has a lot of good ideas. It's only fitting I steal another. So I'm gonna add undefined, and I'll show you the way it works. First, I go here. I'll add another keyword after let, so it's keyword undefined. Yep, undefined. Okay. Previous definition of talk undefined with int. Ah, okay. I already have a thing called talk undefined. Okay, talk nil. Let me just make sure if I use it. Okay, I don't use it anywhere else. Yeah. I already reserved talk undefined as the 0th type, the 0th token. Just so I make sure when I zero initialize things, it doesn't have an actual token. So this is undefined. Yeah, so this is a keyword from Zig, the undefined keyword. Do you know how in C you can assign something in A equals 20? In Zig, var A equals undefined. It's equivalent to going just something A, int A, void pointer A, auto A. It's equivalent to that. And this is from Zig. In this language, I want to make it so you always have to assign something initially, right? But what if you don't want to assign something? You want to just for performance reasons specifically, or whatever unsafe reason you have. You want to assign it with nothing, so you can put undefined, and then assign it later. The reason why I'm doing undefined now is because I want to work on my type inference without assigning a type from its initializer, right? If it's just A equals 20, you already know its type. It's an I32. If I write undefined, I can safely put a typevar here and then infer it later. This is a minimal. Yeah, Jai uses something like dash dash if I remember correctly. Oh yeah. Well, the language changes a lot. Yeah, the language changes a lot. Wouldn't be surprised if I still use that. All right, so let's add the undefined keyword. Yeah, so we added the tag here. We can go inside the parser. Oh, we can just run it as is and see what it says. Oh. Okay, well we don't want j.c anymore. This is useless to us. Okay. Unexpected, undefined, expected expression, which means I need to insert it in the expressions. Undefined gives me nightmares in JavaScript since it has two different representations to do almost the same thing, null and undefined. Yeah, I don't know why, like, undefined is good as is in JavaScript. I don't know why they added null and undefined. Imagine, like, they do have different behavior, but imagine, like, it could have been worse. It could have been worse. They could have done, like, I don't think they'd change the truthiness, but I just thank God that they're not that different. Okay. Talk undefined. So I just yeah. Node equals ir node t. I'll just make that node undefined. So I have to create another AST node. Just another kind. Okay. Node undefined. It's not type bottom. It's just type info. Okay, and then good. Oh yeah, ir dump expression. I need to add an entry for that. Just gonna dump it. I don't know why I waited. Okay. Yeah, so let a equals undefined, and then you're reassigning it a equals 20. Good. Good. Perfect. I wonder, here, v equals a plus 20. I'm using a before it even has a type, right? And the plus 20 won't coerce it to anything. It shouldn't coerce it. I wonder if this is possible in Rust. Let me just go to Godbolt real quick. I liked the one thing in Swift that it does not provide you with keywords like int and float. It's all defined inside the standard library. Does Swift have these like uppercase floats int? Okay, it's like Python. Yeah, it's defined in terms of classes. Okay, let's also go to Rust. Yeah, this is what I always use. I just go to Godbolt and I just see what Rust does because it does type inference pretty well. So let a, and then a equals 20, and then b, let b equals a plus 20. Unused variable v. Used, yeah, okay, because a used binding can't be initial, it has to be initialized with something. Okay, so I missed that. Okay. Well, I mean, what does Zig do? Well, I know what Zig does. Zig doesn't care, because it's an unsafe language. Well, alright, let's call the type checker. Let's go main, uncomment this, set jump, and then check module. Okay, so he doesn't know what expression this is. Huh. We could make type undefined return a typevar. You know what? That doesn't sound that bad. So the undefined keyword will evaluate to a typevar. The typevar will be stored in A. A gets assigned to something else. Its typevar gets updated to Y32. Yeah, so undefined should create a placeholder. That's not that bad. I mean, I didn't think it was gonna work like that. Typevar. Typevar. Yeah, and then what is this? Is it expr? Yeah, expr dot. Is expr dot type equals TV? Yeah, and return expr dot type. All right. And that makes sense because all variables have initializers. They're always gonna have it. Or they're always gonna have initializers in this language. And these type placeholders will end up being returned by the initializer. So it simplifies a lot of the logic, really. Yeah, clangd is amazing. Yeah, clangd is great. Clangd is great. It saved me in a ton of places. It just makes things so you just hover over anything, you just go exactly where it is. It's one of the best language servers, state of the art. Okay, so let a equals something. Unexpected question mark. Oh yeah. Unhandled expression kind 1. What's number 1? What's expression kind number 1? Oh, let decal. Okay. Yeah, this is my abstraction around variable declarations. I commented that. Yeah, so node var decal. I changed this to a let decal instead. Yeah, it used to be like node var decal. And that used to translate to a simple that. But I just translated all of those into lets. Less coding to deal with. Makes things easier. Okay. Creates new placeholder for time. Okay, case. I mean, how's this even defined? Okay, so it takes in a pattern and a expression. Yeah, okay. Check pattern. What I want to do... Okay, well, I want to check the left-hand side. I'm going to evaluate the left-hand side. Expr d let decal dot expr. Okay. And then C pattern. Yeah, good thing I already have these helpers for this. Let decal pattern with the expressions type. Okay. Check pattern. Okay, makes sense. Return expr, what's called type unit. Yeah, because this let decal is a statement which has no type. Type debug stir. Okay. This is the like debug printable representation of the type. Pretty simple. Okay. Case type var. Oh yeah. Let's make a question mark. Whoa. That doesn't seem right. Okay. Yeah, this it's not a d type var ref, it's a type d type var type. I'm dying here. Sorry about that. Okay. This isn't a ref to another type var, it's its underlying type, and sometimes type vars don't have underlying types. Yep. Okay. But if it does have an underlying type, you'd want to print it. Also, I want to add... I'll do that later. Okay, so when it equals type infer, it doesn't have a type. We're really only using this as a placeholder for now, so I'll just write... I think I'll just write the what is it? What's good, LM? Ace, I know that's you. How are you? It's probably really fucking late where you are. Anyway, I continue what I'm doing. So if typevar type equals infer, that means it doesn't have a type, which means we refer to it by its number. That's fuck the fact you know based on that. Yeah, I know it's you. I know it. I can tell it's you. Okay. When it's not equal type infer, which means it has a type. You can write something like dots. I'd wanna write something letting it know that it's typevar, or maybe not. I think I'll just write fake news. Okay, so if it doesn't have a type, we refer to it by it's just numerical number. Okay. Yeah. So A0. Its type is undefined right now, so this is just a whole placeholder. So this is just 15. Well, 15 is an index of the type table. Uh, right now, this is just a what is it? Typevar, yeah. And then eventually, when you'd want to do this, it'll replace the typevar with 20. Okay, mismatch cannot perform that. Well, obviously not. Have to do what was it? Unification. I don't want to do unification of from Hindley Milner yet. I don't want to do that yet. I know it's giving me an error because it doesn't have a type, and I know it doesn't have a type. But there should be a standardized way to do this other than copying error messages around. What's the setting? Okay, cannot perform type hole equals either_d2. Well, it can, because for one, this is an equals operator. Okay, so I need to add. Yeah, I don't like adding all of these things. Expert lines. Okay, equals talk assign. Uh, okay. If type kinds. Yeah, if the type kind of left hand side uh is a typevar. Okay, else checks, was it C type is set. So it sets the right hand side type is equals the left hand side type. Okay. Let me do that. Doesn't that make things easier? Okay. Typevar replace left hand side type with the right hand side. Okay. Yeah. So If the infix operation is a assignment, and the left-hand side is a typevar, it'll replace the typevar with the right-hand side type, and the expression type work on the left-hand side. It'll be a lot easier. Okay, well, let's test that. Wow, look, see? A0 equals I32. So I think that's like further on type inference. You'd obviously not want to be able to do A plus 20. Are you allowing shadowing? In the same scope. In the same scope, no. In the same scope, no. But so let's say I have A equals 20, and then A equals 20. This is defining a new variable, by the way. I'll explain how variables work in this language. I want the syntax or variables to like resemble Haskell. So let's say you have like ABC equals 20. This is an immutable variable. And since variables are immutable, any further assignments you always know are declaring new variables. Yeah, so you can shadow. You can shadow this thing because it's not in the same scope. Yeah, so but you can't do this. ABC equals 20. You're just defining another variable in the same scope. Yeah. Error. Variable ABC already exists in this scope. Variable ABC declared here. So you can't do that. But what you can do is you can assign to mutable variables as many times as you want. Keep in mind that the mutable variable isn't declared. Yeah, well, you'd think, yeah, it is, you'd say Python style variables, but all this is really declaring a new variable. You're not reassigning. You're always declaring a new variable, and this is like Haskell style. Like do. So these are all new variables. This is Haskell style. So this variable declaration style is always a shorthand for let equals 20. I meant syntax wise. Yeah. You're right. You're right. The way the reason why this syntax isn't ambiguous at all is because you can't reassign an immutable variable. So it's always creating new ones, etc. So it's a shorthand for ABC equals 20. But for mutable variables, obviously I'm going to add mutable variables in this language. This language is going to be like a functional C, basically, right? And if I want to make it a functional C, I want to add mutable variables. And mutable variables are mostly okay, right? If you can have mutable variables inside a function, and if it doesn't touch the outside, it's still pure, right? I don't see why adding the restriction of immutable variables only. So I'm adding them to my language. Yeah, Python also inspired by Haskell. Yeah. It's a simple syntax. So I'm gonna define mutable variables are always with a dash at the front, right? I could have done variables like this, like the prime, a variable prime, but I always felt that this looked nicer. And the difference, all mutable variables look different, right? So this is an immutable variable, you can't change it. But this is a mutable variable because it has a dash at the front. That's this is how I'm going to do mutable variables in my language. So you can paste it as much as you want. This does not create a new variable. This is always assigning to something else. But what you can do is you can declare them with let, and there's no syntax ambiguity, and it always knows you're creating a variable. I mean, this also like this syntax is quite different. It's the immutable declaration syntax is different to the mutable declaration syntax. The reason why I made them different is because you're always going to be declaring immutable variables more often than mutable variables. So this shorthand is nice. So that's what I'm going to end up doing. Mutable variables with dash ABC. Okay, where were we, actually? I got lost. Okay, see infix type resolution. Yeah, so that we see was undefined. Yeah, and you can't do this, by the way. Like, you shouldn't be able to, like, you can't. Variable ABC exists in scope, so it has to be an immutable. Immutable. You have to make more changes in refactoring if immutability is part of the name. Yeah, that's right. That's right. I took that into consideration as well. But really, refactoring, I'm not even talking about modern IDEs. I'm just talking about decent text editors. Most of them allow you to just highlight, and I mean, in VS Code you can do Control D, and then just replace them. Uh, yes, I did take that into consideration, like refactoring a variable name. But in reality, it's such very little cost. It's a very little cost. So I say this is fine. I say this is completely fine. I don't take an issue with it. Okay. Yeah, so right now we're inferring types. So without its declaration, the types are known. And with it, the type's known. That's an I32. Okay. Now, let's do another kind of inference. Let's do like add takes in A, B equals A plus B. Alright, and add is typed with an I32. 32. Okay, and now I want wait. Okay, let's just assume this is a type. Oh, what was I saying? Julia uses exclamation mark or bang in front of a function to tell if the function is going to mutate the variable or not. Similar to that, but tells if the variable is mutable. Yeah, that's right. I don't know. Wait, where do they put it? Here, I'll look it up. Here, we'll look it up now. Julia mutability. Okay, you know, fuck medium. Okay, do they do it like this? Like it's not a function call like Rust. It wouldn't be like a macro call. I think it would be like, I'm assuming it'd be like a this, a exclamation mark. Yeah, I mean, I assume it'd be like that, or like this. I mean, in V you'd always have mut A, mut B. Anyway, yeah, it's a small hint. It's a small hint. It's more of a rubber stamp or to warn user. Yeah, yeah. And Spy says medium is extremely annoying lately. Yeah, it is. Yeah, I think like there's a service called Freedium. Freedium. Yeah, breaking medium paywall. So you can just paste your articles in here. This is great. Okay, so this is the type of inference I want. So you know the types of A. You know the types of add. It's A and B equals A plus B. And that just takes in two I32s and returns an I32. So you know the type of add. And if you're applying ABC to add, and ABC is a type hole or a typevar, you'd want to assign an I32 to that. This is one of the basic instances where you can do type inference. So, let's do that. Let's implement unification. I feel like this would be a good time to implement. Are you going to support lambda calculus? Depends on what you mean. Depends on what you mean. If you mean like because right now this does currying, so it, I don't know what you mean by lambda calculus. It's pretty functional, but it's not lambda calculus. Type T. Currying, yes, yes. Currying will. I mean, when I saw currying, it's like love at first sight. Yeah, I'm gonna do. Currying is first class, right? Because I have these function declarations. I have I32, like this returns a function which returns a value. Currying is going to be first class in this language. Yes, you can do like v equals partial application, and then you can just call v again. Yeah, it'll be first class in the language. Right, C unifies type T, LHS, IHS. Yes, if you put in a type hole and I32, then the type hole will equal I32. Things like that. Yeah. Lambda calculus takes one argument and spits out an argument that can be passed to another function. Yeah, all functions take one argument in lambda calculus. Yeah, so currying and functions, when you call a function, it returns one value. That's all going to be in this language. With quite low overhead as well. I'm going to try and do closures with extremely low overhead. And I wrote a ton in my design doc about how I'm going to implement closures. Let me see, closures. Yes, I wrote here something here at the top. The entire language is available without a heap allocation. That's one of my design goals, right? I want the whole language to be available without heap allocation, and closures are no exception. Yeah, so a closure, yeah, so the closure representation is a fat pointer. It's a function and data. A closure call takes in two arguments, a function pointer and some closure data. Performs a closure calling convention, passing the closure data inside RAX, which is ignored. Yeah. The function pointer and closure data pointer are decoupled to make sure they get treated as value types, things like that. Well, where will you store them if not on the heap? Okay. I think you're assuming. I think you're talking about the closure data. Everything is going to be by default. Everything will be taken by value. I think this is how it is in V. Like by default, let's say you have like a function. Listen, a equals 20. You have a function v equals x, it returns a plus x, right? It'll copy this by value. It'll take everything by value by default. And if you're taking a reference, you're gonna have to deal with the lifetimes. Yeah. It'll be a C++ lambda thing. It'll be quite unsafe, really, but that's the price you pay for these free closures. A nice implementation is what D does in dlang. They have a garbage collector and everything, and they automatically promote the closure data to a heap allocation when needed. This is not going to be in this language. It's going to be quite it's not it's you're only going to shoot yourself in the foot some of the time. And I'm going to make ASAN, address sanitizer, default in this language as well. So all these things are going to be found out at runtime anyway. Yeah, so everything is going to be copied into a statically known sized struct. So if this is an i32, it'll just be a struct that contains an i32. Yeah, use C++ insight and write a C++ lambda and see what's the output. Yeah, apparently C++ lambdas are just classes. They get desugared down to classes, which is a pretty nice representation, really. Okay. Let's implement unification. So what I want to do is I want to isolate this variable, this thing. This is a function application. So I'm calling add with ABC, and there's two sides to the type. The add has this, and the ABC is a whole, right? It's a placeholder. Okay. Yeah. So add an ABC. Add, you know this type, and this is a placeholder. You know it's a function application, which means the value on the right hand side must be an i32, and then when you run unification on an i32 and a typevar, this is like a placeholder. It'll know that this has to equal this, and then it returns i32. I mean, this is when I say unification, I mean it's quite simple. It's really simple. If you want to know, yeah. So I mean, add takes single a single argument, which is an i32. Add is a typevar. So when you do unification on add and ABC, this is a placeholder, which means this will equal i32. So when you call it, when you get to here, it's known that ABC is an i32 because of unification. All right, well, let's do this. I don't know what it does when it calls. Okay. Yeah. I don't know what that returns. Equals. Okay, it returned nothing. Yeah, type mismatch. I did not see that type mismatch. Okay. Expected argument type i32 got the type hole. Okay, C unify. TI kinds. Okay, if fill it in. Okay. Good. And then now we end up with things like i32 plus u16. You'd also want to do things like what else? If LHS kinds return IHS. If you have a loop where you do not know the upper bound, will you use unbounded stack space? Yeah, they're having a discussion about closures. I'm just trying to slot myself in here. Yeah, I mean, the way V does closures is that it always allocates the closure data on the heap. Okay, if the left hand side type, yeah, so bottom coerce everything. Okay. Okay, and then we both end up with random types, cert not reached. Okay, C unify. Where is it? Node cool. Yeah, good thing about cool everything being in a code representation. It makes things a lot easier. It's a really nice abstraction. It just makes calls really easy. Okay. Okay, argtype. DFN arg. Yeah, and just do a unification. Unify. Okay. If LHS equals. Okay. Wait, did they just do it? Oh, it just did it. Okay, it just did it. Oh, would you look at that? Let ABC equals undefined, that's a type hole. There's nothing in it, so let's just call it without it. You can see it. ABC has a type hole, there's nothing in it, that's just a typevar. And let ABC equals undefined, because you're just calling it. Yeah, and then here, V equals add with ABC. You're calling add with ABC, so it takes the adds type returns, it takes in the i32 and returns a function. Yeah, and then it does unification, so it unifies with i32 and ABC to return yeah, type, and it like removes the type var. Yeah, it removes the type var. Stack space is usually limited to 8 megabytes on Linux and a lot less on Windows by default. You know, I really like I mean Linux being Linux having a size of 8 megabytes is a blessing and a curse, because we'll get whenever I like do a Stack Overflow and I look in the GDB output, it's like a million stack frames long. Oh, no, blow my nose. All right. Well, that's easy. That's like basic unification. Let me add all of these. I don't need check copy. I don't. Yeah. What do I write for the message? Just checker. Stream 6. Basic. Okay, basic typevars and unification. Commit. Okay, what time is it right now? Do I have time to do function type inference? Okay, I do. Let's do function type inference. You storing the structs. No, I think Spy. I think you're taking it from the perspective that uh you don't have to heap allocate every single time. I think how do I explain it? how do I explain it? When the closure gets desugared, all of this is just a struct. So if you're creating closures in a loop, you're just allocating a struct, and that struct is a static store, like automatic storage duration, and it gets deallocated. There's no heap allocations involved. In reality, in V, we never have to heap allocate. It is very rare we need to heap allocate, only when we're accessing variables in a different scope. And even that is unsafe. Alright. Let's do function type inference. So this is an add. Add is being called with 20 and 30. That means that type is an I30. No, that means that type is a... Yeah. Yeah, so when you're calling this, add goes to I32. I32. But when it's here, add is simply typehole, uh, okay. Add typehole, and then when you're calling it, it does that. Yeah, it doesn't seem too hard. It doesn't seem too hard really. Okay. Node proc decal. Okay, function type inference is not implemented yet. Okay, create typevars. Needed. Well, first I need to make sure they all have these same arguments. Argument like. All right. Let me just add the types back for a quick demonstration. Okay. You see here it says add equals this, and then add is a switch, and on one of the cases it does that. How functions? You know how in Haskell you can do this. You can pattern match multiple times. It's a really nice syntax. I like that syntax. And how I abstract against that in the inside the intermediate representation is I have just like a list of patterns, and that's implemented as just like the switch here. So this is the first pattern, and that returns that. And they're just matching on tuples. So what I need to do is I need to make sure that those tuples all their elements are the same length. And how am I going to do that? Yeah, 4 equals 0. C equals here. Patterns. Unification is tricky if it has to work in both directions, like in Prolog. Yeah, it is tricky. It is tricky, but that's for that reason. I'm not doing things like implicit polymorphism, so it doesn't it generics has to be explicitly done by the user. There's a lot of like simplifications that make things really trivial. Yeah, function argument length mismatch on pattern. Yeah, patterns, I, and that has a location. Okay. And what's the pattern length? Okay, pattern length is 2. Okay. I'll make this -1 just in case. Okay. All right. Now what you want to do is, let's say, eval is 2. You want to create a function type like that, right? You want to, there's 1 and there's 2. Okay, and that's simple. You know what? It's so simple, I'm pretty sure it can fill it in for me. No, it can't. We'll do... Set the length is greater than 0. All functions have... Okay. Function type equals type. Typevar new. Yeah, type function. Type infer. Okay. Yeah, if this is the last type, I plus 1. It's not varb. What is varb? Oh, the varb pointer. Yeah, if this is the last type. Let's type var new. Else, say type. Is it type infer? Else, it's just going to be set. It's going to be set elsewhere. Well, takes in an argument, right? Oh man, this is annoying. This is annoying with my. This is fucking with my head. Typevar new. Oh, okay. and type equals. Alright, false alarm. It's actually not that hard. Okay, good. Let's print it. Okay. Function length, function argument length mismatch. That's len. Compare type info. Yeah. This is the code I use for interning types. Okay, type. Okay, typevar. Good. Where's this from? Give it open up GDB. I don't even have it. Yeah, I've got a. Yeah, I have a new computer. New install. So I see to install it. Come on. Alright. Type kinds. I get to here. Okay. Well, I'm not even printing it. Okay, good. Yep, type 15 to 15 to 15. I don't know why it says 15 though. Oh, it has to wait. Return is this. Does that work? Huh. I mean, that should be right. I mean, it seems right. Is it really 15, 15, 15, 15? Oh, the type and turning. Oh man. Okay. Case type var. Types with not equal. No. Okay. Yep. Break. Return false. They're always different. Okay. That's, thank God. Like type and turning. If you get it wrong, it destroys everything. Okay. Now all these types don't go to 1. This is 15, 16, and 18. I don't know why it goes. I don't know why that's 18. It should be calling it the right amount of times. Ah. Oh, what does it do? Like fix it later. You know, not enough brain cells in the world. Yeah, we can deal with an extra hole. Okay, that's the type. Okay, if the type is type infer, make sure they have the same argument length. You know, just slap all this code in here, and then there's our type, with a bunch of holes in it. Okay. Var.type equals function type. Okay. Type mismatch. Cannot perform I18 plus I16. Okay. So that error is coming from add getting the type with all these typevars, and then trying to type check the inner. I only wanted to type check when add has been assigned all the types. So when there's no typevars left. Okay, create the typevars. What I wanted to do is not create a typevar for the last. Yeah, I don't want it to create a typevar for the return value, because that will be inferred when its arguments are found. Okay. So this is inferred. Yeah, so don't check the patterns, don't check anything. Else run this. Okay. Oh wow, it already did it for me. Wow, look, it says I32 here. Okay, so that's really halfway there. That's it's the beauty of these like functional abstractions. Oh yeah, Spy says, how do you represent scopes in your compiler? Pretty simple. It's actually pretty simple. I'll show you how they're done. Okay. IR scope T. It's just a struct. Okay. A scope T has its parent, and it has a list of locals. And these locals will be an STBDS style. Yeah, STBDS style dynamic array. So the parent can either be a valid pointer or null. Yeah, it's a linked list. But this linked list doesn't encounter much overhead. Yeah, it's a tree of lists. So when parent equals null, it's a top level scope, and if it doesn't equal null, that's its genuine parent. That's where the null stops. So how it works is, in these nodes, there can be a here. So let's say, for example, let's go like a equals do, v equals something. V is in a different scope to a, and how that's represented is in the AST. So in a node do block, the node do block here, it'll have a pointer to a scope, and have a list of expressions. So that's how it works. The scope is always it just contains its parent and a list of rvts. So this is a reference. Yeah, this is just an index to a list of variables. So it only stores the indices. It only stores the indices. Do you have a global scope? Yeah, yeah. Right now I'm in the global scope. So I'm doing things in the global scope. But if you go into a function, so main, right now I'm not in the global scope. Now all globals can be referenced out of order. So you can do that. Wait, no, that's not out of order. This is out of order. So all globals can be referenced out of order. That's eventually what I want for this language. That's why I made a distinction between a global scope and the inner scopes. So the global scope is always a null pointer. Yeah. So right now we're working in the global scope. Okay. This works for now. So add 20 with 50, and then good. I mean that already works so far. I mean that's great. So I32, I32, and I15. And if we use we call add again with like false, it should raise an error. Should it? Okay, well, nice bug. That's a cool bug. Do you have any predefined variables or functions? There is no standard library yet. But I want to add predefined functions. Like I want to add the map functions predefined, and all these things. It'll be in the built-in module. Yeah, so some things will be all predefined in the global scope. Okay, so right now this is a bug. Add with false. He has built-ins. Yeah, it does. It does have built-ins. But there's no namespacing, so it gets out of hand pretty quickly. Okay, add with false. That assigns bool there. It should not. I don't know why. I don't know how that's happening. Node core. Okay, C unify. Okay, I think what's going on is that the LHS kind is always a type var, but it it has a it's already assigned a value. So I think we'll get the type infos. Type info. So type info, TI info. I'll just do this. LHS. Yeah, that filled it in pretty good. And the right hand side. Okay. And unreachable. So then we'll just do like a CS set. Is it C type of set? Yeah, they should have an on error. Okay, and pass in the location of the expression. Type mismatch. Expected bool got I32. Okay. Wait. Expected bool. I don't want to do expected bool. I want to do source and of. expected source. Okay. Where is it? Well, it should expect bool. I don't know what the issue is. Also, unify doesn't return anything. Does it? No, it should return something. I don't know where the error is coming from. dfunction.arg. Okay, the archetype is a boolean. That's right. I don't want to say expected bool. I'm pretty sure it shouldn't. Okay, the RHS is the archetype. Ah. Then why are they flipped? I don't know why they flipped. Okay. It's really annoying. Expected LHS. Okay, expected I32 got bool. Alright, that makes sense. You're using add before it's without its type. You're giving it a type by calling it, and then future uses will make it an error. Okay, what I want to do though is I want to infer that final time. Fuck. Yeah, node form. Okay. CUnify returns something. Let's just assume that set does not equal type infer. Okay. When you call a function and it doesn't return, if it doesn't return the function, if you call a function and it doesn't return the function, that means it's done calling, with arguments. Okay. No. If you know what I want type get to return. Actually, wait, no, that's not right. I mean type kind. Is it ret type? Yeah, if dret is type var, that means the infer the return value. Okay, and what I want type kind to return, if the type info kind is a type var and it's type infer, return type kind of that. Yeah, if because you can replace typevars. You can replace typevars with an underlying type, and I want it to stay that way once I replace them. Which means I can remove the check here too. Yeah, I can remove the check here, because if it's typevar, that means it's empty. It's got nothing in it. Okay. Yeah. One more functions left in the curry chain. Well, I need to store where I get the functions from and their types from as well. I'd store that in a map. So I'd map let's say you have a function type of 1, 2, 3. I'd store that in a map. So map 3 equals my function. So when I get to here, I'd look up that in the map and then check my function. But I think that's enough for I think that's enough for today. I think I've done enough. Good first stream back though. I expect to do a lot more things. Especially work more on the compiler and language. Seriously, one of the hardest things in programming language design, not design, but the compiler implementation is type inference. It's one of the harder things is type inference. Especially when you're not working in a statically typed language, like a hard statically typed language like C or Rust, where you always put the types there. Yeah, it's I finish this. That's the hard part of the language done, and it's just smooth sailing. Like I implement basically all the shitty type checking stuff I need to do, and then they get around to doing intermediate representation, which I'm really happy. I'm really happy for. I can implement like closure optimizations. What's it called? You know, all of the fun stuff. All of the fun stuff. What I came here to do. Here. Yeah, so partial application optimizations and things like that. All of these things need to get done. Here, the type checker. Oh yeah, I was speculating on how I do order of type checking because I want UFCS, so universal function call syntax. I want to add that in this language. I feel like it would be a nice fit, especially when you're piping things. Yeah, the built-in yeah. Yeah, I mean this makes a lot of sense. I'm gonna when the stream's done, I'm gonna put a lot of Hindley Milner resources, like because I did a really bad job at explaining it. So I need to put a bunch of resources down. I'll put that under the stream. Oh, I put that on the VOD on YouTube, or I'll probably make a post about it or something. But other than that, I mean this is a good first stream back. I mean, I know what I need to do for next stream. I know what I'll do while I'm gone. But thanks for coming. I mean, I have 6 concurrent viewers. I mean, that's more than one. That's more viewers than one, especially after that, like what happened to my stream. I mean, I have 73 followers. I used to have like 6. Thank you guys so much. I mean, especially for on my YouTube and everything. But I mean, I'll go now. That's it. It's late. It's 12. All right. Good night. Good night.